continuing with our natural vegetation region, lecture number 7. This is part 2. Let's move on to natural vegetation region number 4. It's called the sclerophyll forest. Now, this type of forest is associated with the Mediterranean climate. And so we can see the sclerophyll forest map very much corresponds to our world locations of the Mediterranean climate. Now, remember, it's a dry summer. All right, so that's kind of critical in remembering what this forest is all about. All right, let's break down the words. Sclero means hard, and phyll means leaves. And so the trees in the sclerophyll forest have hard and leathery leaves to reduce water loss during summertime. Now remember, there are several months during the warm season, where there's absolutely no precipitation. Now these, because of the mild climate, the mild marine effect on climate, these trees remain green all year long. So this is another example of broadleaf evergreen trees. And where do we see that? That was in the tropical rainforest. But here, because of the very, very dry summers, the leaves have to be very, very resistant, right, to the hot and dry conditions. And this is actually an oak tree out in California, and you can just get an idea as to how hard and thick and leathery these leaves are. Let's talk about California, since I like to focus on the United States in this class. Now, the sclerophyll forest in California is locally called the chaparral, and here's how you spell it, the chaparral. And it really, here it is, I got 3 examples of the coastal mountains in California, just covered in the chaparral, and they're kind of like low scrub trees or dwarf trees. And so these trees really are, only 4, 5, 6 feet tall. They're kind of gnarly and dry. And so if you go inland, from all the major cities like San Diego and Los Angeles, San Francisco to the coastal mountains, they're just covered in this low chaparral. And of course, the chaparral is really famous for its summer wildfires. Now you think about it, there's several months of absolutely no precipitation, and all you need is maybe a dry lightning or some crazy person setting a fire or someone not putting out their campfire, and this stuff just goes up, right, in flames. And you've seen it year after year after year. And so here we've got some chaparral being burnt tremendously. Now, there are other types of forests associated with the sclerophyll. In the Mediterranean lands, probably the most famous tree in the Mediterranean lands is the olive tree. And if you ever go there or see an olive tree in California, let's say, you'll notice the leaves are really, really tough with the olive tree. And the sclerophyll forest that you find in Australia is the eucalyptus forest, the eucalyptus tree. And if you're familiar with eucalyptus, it's again a very tough, hard, leathery leaf. The forests in Australia smell beautiful, smelling like eucalyptus. But anyways, it's called the chaparral in California. Let's move on to number 5, the grassland natural vegetation region. Now, this is associated with our 3rd dry climate. It's called the dry mid-latitude climate. And this dry climate is due to the fact that it's located in the interiors of the large land masses in the northern hemisphere, and wave cyclones of mid-latitudes are just dried out. And in the case of the U.S., it's due to the rain shadow effect. So what we want to make sure you know that in this grassland environment, it is of course treeless. There are no trees. It's just grassland, and it's basically too dry. That's the limiting factor for trees to grow. Now, in the United States, the trees need at least 20 inches of annual precipitation in order for trees to grow. And remember, in Pueblo, I think it was something like 12 inches. So basically, here we've got the grasslands in the United States, the prairies actually, and definitely less than 20 inches of precip as you move west of the Mississippi River. Now, as is indicated by the coloration, there are 2 types of grasslands, and we can well illustrate that in the United States. There's tall grass prairie. It's shown in the darker brown, where the grasses can grow up to 6 feet tall. And then there's the short grass prairie, where the grasses are just an inch or so tall. I just want to kind of show you that. Here in Lincoln, Nebraska, you find some nice tall grass prairie where the grass is, and this is a park, and so they've kind of cut the grass so you can kind of walk around in it. But here's some nice tall grass prairie. And then at the base of the Rocky Mountains in Wyoming, the rain shadow, this is some short grass prairie in Cheyenne, Wyoming. So you can definitely see the difference. Yeah, so let's focus on the United States and the short grass and tall grass prairie. If we do a west-east transect across the U.S., I mean, there's a distinct transition from very, very dry to less dry to moist. And so out in the western U.S., we have our dry subtropical climate, so we've got desert. Then things get drier as you move past the Rockies with the rain shadow effect. And this lighter color is the short grass prairie, right? So full on rain shadow effect. Then as you move eastward, closer to the Gulf of Mexico, the fronts start to pick up a little bit moisture. And so you wind up with tall grass prairie. And so a little bit more moisture than, say, 12 inches allows the grasses to grow. And then as the fronts continue to move further eastward, they're picking up even more moisture from the Gulf of Mexico. And so now we have annual precipitation above 20 inches per year, and we have our moist forest climates of the eastern United States. Let's move on to the sixth one, and this is an important one. This is our forest, and it is a mouthful of a term. It's called the subtropical broadleaf evergreen forest. So we've seen broadleaf evergreen associated with the tropical rainforest, right? Because of the continuous growing season there. The trees remain green all year long. But this is not a tropical rainforest. We're a subtropical rainforest. So this, like I said, is associated with our moist subtropical climate. And they're just focusing here on southeastern United States and southeastern China. Right? So southeastern China is another good example. All right, so we're subtropical and we have mild winters. And so our winters average above freezing, if you remember, about 50, 55 degrees average, of January. And so because our winters are mild, averaging above freezing, there are some species that are broadleaf evergreen, not all of them like in the tropical rainforest. And that, as a matter of fact, there really are only two species. And you should be very familiar with these two types of broadleaf evergreen trees. The live oak, right, and they've got relatively small leaves, and they keep them during the winter time. If you ever really look at a live oak leaf, they're really tough leaves. They're really almost kind of like sclerophyll to be able to maintain, occasional freezes. And the same thing with the magnolia. That's another tough leaf too. In order to be able to remain green during the winter with occasional freezes. But those are two examples of broadleaf evergreen. Now, the funny thing is they named the entire forest after this, unique phenomena of having just two broadleaf evergreen species. Now, the rest, are deciduous trees. We do have a period of major leaf drop, and we do have, needle leaf trees, various types of pines, but for some reason they're just calling it the subtropical broadleaf evergreen. And I guess the reason why they're doing that, because we really do have a lot of similarities to the tropical rainforest. Like I said, we're not a tropical rainforest here. We're really a subtropical rainforest. And so just like we had mentioned, here, if you just think in Louisiana, we have abundant epiphytes. Probably our most famous epiphyte is Spanish moss. Plants, attached to the trees, and then there's ferns growing and other types of moss and lichen, very, very common around here. Now, lianas, remember those are woody vines? This is actually my backyard in Baton Rouge. We've got muscadine grapevines right in through here. Look at them just kind of tangling on up, and just as lianas do, they grow up from tree to tree up to the top of the canopy, searching for sunlight. Now, we don't ever get any muscadine grapes, because the birds get them, and the grapes are all way up in the top of the canopy. And And you've seen this before too. Here's another liana. This is like poison ivy and poison oak. And so they start out as little little vines, little green vines, on the ground. But through time, the vine hardens, and so you wind up with these woody vines. All right, and so that's a nice example there. And then buttressing. And this is my front yard too. I'm giving you a tour of my yard. And this is just a regular oak tree. And there, this is no great buttressing, but I know you've seen, and you probably in your yard, you've even got better examples of buttressing on our tall oak trees here in South Louisiana. Now, even though we do have a lot of similarities to the tropical rainforest, there is one big difference in our subtropical forest, is that we have much less speciation. You can't find, hundreds of different species per square mile. In our virgin forests, you would probably, like I had mentioned in the earlier lecture, maybe 20, 30, or 40 species. And that's because we do have a shorter growing season, about 2 to 3 months of dormancy, right, during the cold season. Let's move on. Let's move to the northeast United States. All right, so just north of our climate. It's called the mid-latitude deciduous forest. And so here we've got the northeast U.S. and a good bit of Western Europe and northern China. All right, so this very much is going to associate with the moist continental climate. And so we've got severe winters, remember, averaging well below freezing. And so trees have to drop their leaves during the winter months because the soil water is frozen. It's frozen. And so the trees have to go dormant. And it's almost kind of like a drought, really, because since the soil water is frozen, the roots, the water is unavailable to the roots. So it really is similar to drought conditions. So the trees have to be deciduous. And here we've got this is a classic picture, probably what, here we are up in Detroit. And, the classic gray skies and snow cover and kind of the bleak appearance of winter in the northeastern United States, north central U.S. Let's move on to number 8, natural vegetation. It's called the boreal forest. So this would be easy to match up. This is, the climate, the boreal forest climate was named after this cold northern forest, only found in vast areas in the northern hemisphere and other places, as I'm going to mention in just a second. All right, now what the boreal forest is, it's a needle leaf evergreen. All right, so it's evergreen, remains green all year long, but it's needle leaf. All right, and so here is a good part of where you're going to find the boreal forest in Alaska and Canada and in northern Europe and Russia and into Siberia. But the important point is that you don't have to go up to Canada, all right, or go to Siberia. You can actually find the boreal forest on high mountaintops. So, it extends south into the United States, where we've got the Cascades and the Sierra and the Northern Rockies and the Southern Rockies. And as you move up in these mountains and higher elevations, the climate, mimics that of the boreal forest up in Canada or Russia. And so here we are in the Rockies, and here we've got some blue spruce, and so it's the boreal forest at high elevations. The other thing about the boreal forest, it is a single species forest. We've got short summers, relatively cool or mild, and again, the speciation is kind of critical. We started out with hundreds per square mile in the tropical rainforest, and now due to kind of the short growing season, we're down to a single species forest over hundreds and hundreds of miles. And so you can see there's just pure stands of spruce, fir, or various types of pines due to the short growing season. And here we are up in Canada, and here we've got some of the boreal forest here. It's dense in southern Canada if you're thinking of North America, but as you move further north up into Canada, the boreal forest gets sparse and fewer and far between. And there's going to be a certain point somewhere near the Arctic Circle where it just becomes too cold in this climate for trees to grow. And we reach a point where it's called tree line, where the trees stop growing. There is a subtype of the boreal forest. It's called the coastal needleleaf forest. So it's another, needleleaf evergreen forest, but it's coastal. And so this is a subtype, so it is shown on our boreal forest map. And here it is here in the lighter purple. It's a coastal needleleaf forest. It's associated with the marine west coast climate, particularly of North America. So, Washington State, Oregon, up into British Columbia, and even into Alaska, believe it or not. And so you're going to find a lot of pine trees, Now, especially we had mentioned due to orographic precipitation, we've got the giant trees, the giant redwoods and sequoias are really famous. And so it is noteworthy that these are needleleaf evergreen trees. And here we've got some giant redwood trees. And they're very, very tall. That's a point that I want to make. Yeah, redwood trees, right, in this coastal needleleaf forest found in North America are the tallest trees on Earth, right? They're up to almost 400 feet tall. I mean, that's amazing. And here we've got people there for scale, almost kind of look like ants. Now, in the tropical rainforest, those trees, they'll max out at about 150 feet tall, 150. So these are much taller trees. All right, moving on, let's go further north. Let's move on to the tundra natural vegetation. And again, the climate was named after this vegetation region. And again, this is a treeless environment. It's various types of grasses, herbs, and moss, and maybe wildflowers. It's kind of a pretty picture. But in reality, really it's kind of a bleak environment. Here's a kind of a single grave marker in the bleak tundra in Alaska, actually. So it's just simply too cold for trees to grow. Now remember, the summer, right, or quote-unquote summer in the tundra climate, it really is 3 months where temperatures average just above freezing. And so that just simply is not enough of a growing season to get trees to grow. There are 2 types of tundra, and the first type is called Arctic tundra. And here we've got a map showing the tundra in purple, centered on the North Pole. And so our first type is Arctic tundra, and you're basically going to find it north of the Arctic Circle, and it's kind of this dashed line here, more or less north of the Arctic Circle. And so as I had shown you that picture in Canada, you had the dense boreal forest, and then by the time you go further and further north, it gets colder and colder and colder. And that boreal forest starts to become, few and far between, and becomes very, very sparse until you hit tree line, where it's just simply too cold for trees to grow. And you hit tree line and then the low grasses of the Arctic tundra. Now, the other type of tundra is called alpine tundra. And alpine is referring to mountains. And this is what I was referring to with the boreal forest in, say, the northern Rockies or in other high mountain areas. I mean, you don't have to go up to Canada to find the boreal forest. I mean, if you've got a high mountain range, we know as you move up in the troposphere, it gets colder and colder and colder. And so you can actually find, if you've got a mountain high enough, I mean, you can find alpine tundra, boreal forest, and other climates too we're going to talk about. So this is kind of an important summary that I want to make with this figure. Increasing elevation in mountains, all right, here we got increasing elevation in mountains, has the same effect on vegetation types as increasing latitude. And here we're on the bottom, we're at the equator, and we're kind of, moving, to higher latitude locations, maybe deciduous forests, and here's our boreal forest, and then our tundra, and then snow and ice. This would be our ice sheet climate where there's no vegetation. And so you can actually be at the equator even. And here you've got tropical rainforest, and then move on up in elevation, and it becomes cold. It's a shorter growing season, and the trees have to drop their leaves. It gets colder still yet as you move up in elevation, and mimicking the boreal forest climate. And you've got tree line, and then you've got alpine tundra, where there really is, very, very cool summers, just above freezing. And then you can actually move on to the ice sheet climate if the mountains are high enough. So you really, you don't have to go 6,000 miles from the equator to the North Pole. 6,000 miles, pretty much, to see this range in vegetation. All you need to do is take a few hours and drive up a high mountain. Say you've got a mountain that's 14,000 feet. I mean, you can do that in a day. I mean, definitely in a day. So over, a very, very short area here, you can, go from, well, not North America, but you can go from, a deciduous forest all the way to an ice sheet climate over a very, very short distance. So you don't have to go to the equator, to the poles. Yeah, and I got a question here. I mean, so, do you think you can find tundra at the equator? Yes. Right? Certainly it's not going to be Arctic tundra. I mean, it's not going to be Arctic. We're not talking about the Arctic Circle. It's got to be alpine tundra. Now, the only way you're going to find alpine tundra at the equator is if there is a mountain at the equator that's very, very high. So the answer is yes, right? If you've got high mountains, you're going to wind up doing this, starting from the tropical rainforest at the equator all the way on up to the ice sheet climate. And I want to give you two examples on the next slide, two great examples of this phenomena. The first example is in the Andes Mountains. Here, I've got the equator here, where the mountains here in Ecuador, in South America, they're 17,000 feet at the equator. And so here, to the east of the Andes, you've got the Amazon rainforest. And so actually that figure in the last slide, it really is based on what is going on here in Ecuador. And so you start with the tropical rainforest and up to the deciduous forest, the boreal forest, alpine tundra, and yes, the mountains are snow-capped, the volcanoes are snow-capped, and you can even find the ice sheet climate at the equator. The other really good example here is Mount Kilimanjaro in Africa, in the highlands of Africa, not quite at the equator, but close enough. Now Mount Kilimanjaro is 19,000 feet, and again you have all those shifting vegetation types going to colder and colder and colder vegetation types until you actually reach the snow-capped ice sheet climate of Mount Kilimanjaro. I just wanted to finish up by showing you some pictures in the Southern Rockies in Colorado. These pictures were taken at Rocky Mountain National Park, just outside of Boulder. And it's a beautiful example of the single species boreal forest that you can find at high elevations in mountains. And then here's tree line. And so we're going up higher elevation, and so the boreal forest gives way to the low grasses of the alpine tundra here. And here's a nice example again of the boreal forest, single species tree line, and a nice example of the low grasses and vegetation of the alpine tundra in the Rocky Mountains in Colorado. End.